Hey, I'm a mechanical engineer, and this is Talyn Alpha. Today, we're going to build the newest version of my 1-pound bot Talyn, but instead of doing it in 3, 4, or 5 different parts, we're going to try to do the whole entire thing in one go. I am so sorry I have not posted in a while, but I wanted to make the robot and the video the absolute best it could be, and so it took some time to work all that out. But the wait is finally over. Here we are. I'm super excited for this video. I hope you guys are as well. So without dragging things on any longer, let's just get started. Here is the master plan. Looks like a scrambled mess, kind of is, but then again, no. There's a lot of information on here that we're probably going to get to later in a more put together and orderly fashion, but for right now, I just want to show you the dimensions of the robot. As you can see, when the robot's all put together, it should be 12.5 centimeters wide and 16.5 centimeters long. But that's made up of two separate parts, the wedge lifter, which is 5 centimeters long, and then the main housing or frame of the robot that's 11.5 centimeters long. And that, of course, is where all the good stuff like the drive motors, battery, ESC receiver, and servo that will lift the lifter will all live. Very tiny little area. Oh, and I almost forgot to mention, the height of the robot should be no more than 28 millimeters tall, which I'm very excited about. This robot is a little bit larger than I wanted it to be, is a little bit larger than last year's robot, but at the same time, all the parts are bigger, stronger, and upgraded, and I don't think I could have possibly made it any smaller. In fact, if I was going to be completely honest, fitting all of the components inside this frame is going to be difficult as it is. But with all that being said, now that you have a basic rundown of what we're going for, let's get busy actually building the robot, starting with printing the base plate itself. And here we are after the base plate has printed, but this is not just any base plate. Oh no, this is a super advanced base plate. Kind of. As you can see, I have the windows for the wheels cut out and the holes for the side armor pre-drilled. I then also have the drive motor mounts and the servo mount pre-built into the board to save space and weight. Look at those motor mounts, beautiful. Oh yeah, and it's 3 millimeters thick if anyone's wondering. In fact, if you guys want to see the exact design and dimensions, I'll see if I can upload the file to Thingiverse and leave a link for it down below. Now I know the first thing you guys are probably thinking, and that is that 3D printed PLA will not hold up that well in battle. And you're right, kind of. I was originally going to make this out of Lexan, but after I added in all the motor mounts, which again is completely necessary because it saves me a ton of weight, it just became too complicated to be able to do by hand. I know. I could pay some company with a fancy machine to cut out for me. However, I just don't want to spend the money. But that's okay, because I did my best to design the robot in such a way that it utilizes the PLA's strengths and protects its weaknesses. Would it be better off using Lexan? Yeah, sure, probably, but at the same time, I think it'll be just fine as it is. Plus, of course, I'm going to bring a whole buttload of spares. Of everything, but especially the base plate. So with the base plate now made and greatly explained, let's move on to the sides of the robot. For the sides, I'm going to use HDPE, but I'm not going to use it on the front. I'm just going to use it on the two sides and the back. I'm going to go ahead and start cutting down the HDPE into 21 millimeter tall strips. Then shave down the sides of the strip so that they're only about 10 millimeters thick. Perfect, just like these. Now we can go ahead and cut them down to the perfect length to fit the sides. And here we are. Now it is time to secure these side pieces to the frame by drilling through the holes in the side frame into the HDPE. We could of course drill these holes by hand like I've traditionally done, but it's very hard to get them accurate and precise, and when the holes aren't perfect, it stresses me out and it's just horrible. So what I've done is, through the power of the 3D printer, I've printed little jigs that perfectly line up the side frame holes with the base plate holes. I have this shorter jig made for the back side, and then I have this longer jig which I've yet to put together for the sides. All we'll have to do is make sure the jigs are perfectly centered, and we should be golden. I'll probably upload the files for these jigs as well, but they're like completely useless unless you're building the same exact robot. Like that. Now it does stick out just a hair right here and I think here, but that's just because my miter saw isn't completely squared away, and honestly that is just barely noticeable as it is. I really like that. That's very precise. So as you saw in the video, these 6 screws are all long screws, so is this middle one right here, and then the other 4 are little tiny short screws. The long screws stick up well into the sides, making sure it has a nice firm hold, whereas the little tiny screws barely poke up. And now the reason why I use these tiny screws at all is so of course I could use a long screw in the corner to kind of help get it all to be one solid piece. That's also why there's this somewhat awkward gap at the front, so I can insert long screws which will hold in place my Lexan sheet, which is going to serve as the front of the bot. You know what, I'm actually just going to go ahead and cut out and screw on that Lexan piece so I can show you guys what I'm talking about. Voila! Voila! So I have the front Lexan plate secured into both sides of the HDPE with double screws, and then I have little HDPE supports attaching the front Lexan piece to the frame itself, so the whole thing acts as one solid piece. And not only that, but these supports will also help hold the top cover in place, which is not this. The cover will be comprised of 3 different parts. One will sit on each side and bolt into the side frames and the front support. And then the third one will actually be the lifter, and that's going to go right in between the first 2. The cover should help make everything a lot more sturdy, but at the same time there's literally 0 movement in any of this. This is very solid, which I'm loving. So I'm going to go ahead and cut out those side plates and bolt them down, then we can move on to the lifter. Perfect, look at that. Absolutely beautiful, ready for the lifter. So let's go ahead and cut out the Lexan strip we're going to use for the lifter. Fits nicely. And while we're at it, let's make something super simple that can hold this while we bend it. Like this. This will not only help keep the Lexan perfectly straight, ensuring that we don't bend it off to some weird angle, but also with the help of this block will help make sure that everything that needs to be flat will stay flat. I am going to go ahead and cut down this Lexan just a little bit because we only want the lifter to be about 2.5 inches long, and if it's any longer or shorter our angle will be off, you get it. But after that we are ready to stick it in the oven to help get it nice and wobbly so we can bend it. Tastes like plastic.
As you can see, I built up the height of the bending apparatus to match the height of my robot. I did this, so now I just need to bend the Lexan to be flush with the counter, and I'll know for sure that the angle is spot on. That's why I'm repeatedly rubbing it back and forth on a counter to make sure that it's completely flush.
Those look really good. Yes, I made 2 because I need spares, and they're actually exactly the same angle, which is super awesome. So now I'm going to go ahead and use my hinge jig to drill hinge holes into the robot frame and lifter arms. But before I bolt it all together, I'm going to cut down the front part of my lifter so that they're only about 1/2 inch long. I know that seems crazy at the moment, but give it a second, it'll make sense. Look at that lifter. That's really raising my spirits. Oh my land, that was bad. So as you can see, I bolted the hinge on the inside of the frame, and that's because it wouldn't quite work right or fit if the nuts were facing the other way. But it also has the added advantage of helping me self-right, because once you extend the arm to about 90 degrees, they're bouncing on the bolts, and since the bolts are mounted high, it'll tip over to the bottom, which is super cool. But what about the actual lifter or front wedge? Well, we could make this out of metal like a sane person, but I'm just going to go ahead and make it out of Lexan like I have basically everything else. I think I can get away with this though, because as you can see, the wedge is very low, and as a result, the spinners should more glide across it than they should hit it too awful hard. With that being said though, it only applies if I hit them or if they hit me dead on. If we hit each other at a slight angle, which is more than likely to happen, they're going to hit the side of the bot, which is a much larger target. And that's a concern of mine, because not only would that put a lot of pressure and force on the lifter itself, but also on the hinge, and who knows what can break. So what I've done is I've made these little tiny pieces that will bolt on to the inside sides of the lifter and help lock it in place. As you can see, these parts have a cutout that allow them to push right up against the frame of the robot. This way, if the lifter gets hit, the whole robot will feel it instead of just one isolated area, which will in turn make it a lot stronger. And since my hinge has a little bit of side-to-side play, nothing much but enough to throw off my lifter, I've sharpened the bottom of these pieces at an angle to help guide the lifter when it comes down. So even if it is a little bit off, it'll hit those angled pieces and center itself. Now this is all fantastic and I'm super excited about it. However, there is one big problem, and that is these parts are 3D printed, and this is an area that's definitely going to get hit by a spinner or something at some point in time. It is a very vulnerable area. But regardless, I think I'm just going to print out a whole bunch of spares and run with it, hoping for the best. You know what? No. The more I think about that, the more ridiculous it seems. The PLA can and will get broken, and it's also pretty heavy. So what I'm going to do instead is just make the whole front piece, including the corners that are angled and all that, out of one solid piece of Lexan. I'm going to heat it up and bend it. It'll be lighter, it'll be stronger, and I think just all around a much better solution. But it is going to take time to do that, and since the video is already pretty late, I'm just going to keep the wedge I have to finish out the video, and as soon as it's done, I'm going to get cracking on that new wedge. So whenever you see the wedge with the PLA sides, envision the full Lexan wedge. So with all that being said, I'm going to go ahead and mount the side pieces onto the front wedge, but I'm not going to mount the front wedge onto the lifter arm just yet, because we still have to put in the wheels, and when you put in the wheels, it'll lift up the robot. You get the picture. Awesome possum sauce. That fits in there beautifully. And this is actually our first glance of what Talyn's going to look like when he's complete. I think I like it. Now, like I said a minute ago, we're going to have to install the wheels before we can attach the lifter to the front wedge. So let's go ahead and do that. Now here is one of my wheels, and as you can see, it's actually just two Lego wheels on a 3D printed hub I designed. There's a D shaft in the middle, and then there's an expansion channel that helps gives the tire a nice firm grip on the motor shaft. And actually, if you guys want a few of these, I'm going to be selling them for a short amount of time, so link in description. But anyway, I'm going to slide the tire onto one of my drive motors, and this is actually a 6-volt 1000 RPM geared DC motor. It's about twice as heavy as an N20 at 20 grams, but also twice as powerful. I've designed the base plate in such a way that now all we have to do is take the wheel and motor and drop it onto the motor mount. Now it cannot move any direction except for up. So now to stop the motor from moving up and really help lock it in place, I'm going to slide 3 zip ties into the holes next to the motor and close them up around it. Perfect. That is in there very snugly. I did bend the zip ties a little bit before I put them in there because, as you can see, I do not have a whole lot of wheel clearance and I need them to sit as flat as possible. So with that, let's go ahead and put in the other 3 motors. However, you may want to wire them up beforehand because it'll be difficult to fit a soldering iron in there afterwards. I know I'm not going to be able to relay this very well on camera, but these wheels have a lot of grip to them. It is not easy to move it, and the robot's empty. I only used single tires on the last version, and honestly the difference between the two's grip is night and day. I'm really liking this. So with the motors now securely mounted in there, I'm going to get all the rest of my internals, like my servos and my speed controllers, and cut down all the excess wire so we're left with the smallest amount possible. We do this of course to save weight, but also to save space because it is going to be exceedingly tight inside there. After all that, we have pulled out a lot of wire, which equals, 9 grams of weight. So our robot is now 9 grams lighter, which is fantastic, and a lot less wire to try to store. So now it's time to finish off the internals of the robot and put all of this good stuff into the frame. This whole right side of the robot is for our lifting servo, and as you can see, it takes up a lot of space, leaving a tiny little window for everything else. But what I'm going to try to do is connect our ESCs to our drive motors and then push them down to the center middle of the frame. I'll then drop the receiver behind the ESCs and plug everything in, and then hopefully there'll be enough room left over on top of the ESCs to fit the battery in there. Even if everything goes perfectly well, it's still going to be very tight. But with the help of some cardboard and some hot glue, I think we can make it work. So enough talk, let's see if we can make this happen. Okay, so I'm having a little bit of difficulty fitting everything inside this tiny little hole, but I think I have a solution. I can angle the ESCs in the front like this if I cut a little tiny hole in the front of the robot for them to stick out of. But obviously that's like an Achilles heel. Someone can come through and just cut those right out. But if you take a closer look, really the only thing that's sticking out are the actual switches. So I think I'm going to remove the switches and see if I can solder the contacts together to save space. Then I can cut a little strip of Lexan out and glue it over the front of it. If that works out, it will not only open up a large window here, which we should definitely be able to fit everything in, but also still protect the front of our robot, even though the wedge should protect it further, but you get what I'm saying. So I'm going to go ahead and turn on the soldering iron and let's see if we can do this. However, I guess we do first need to find out which position the switch needs to be in. And by the way, I do have 4 ESCs in here right now, but that's just for testing. I only really need 2. This ESC was actually hit by a spinner the last time I fought, and I don't know how, but it still works, so that's cool. Well, the switch obviously doesn't, but the ESC does. Now we can go ahead and plug everything in to make sure we wired up the right side of the switch. And what do you know we did? That's fantastic. Perfect. Now I'll just wrap these with just a little fart of electrical tape to make sure they don't short out if I can find out where my tape starts, and then we can put them in their proper position and start closing everything up. Okay, so it did take some time and some hot glue and zip ties, but we are finally here. All of the electronics are tightly packed in there. We have room for the lifter arm to lift up, and we have a little hole over here that we can stick our battery in, so hopefully we're good to go. So with that, we're now ready to screw back on our top covers, which by the way, this one is going to help hold the servo in place because there's a little bracket that it drops into, so then you put the top Lexan piece on and it can't move anywhere. And then this other one helps keeps our electronics down and in place and also allows us to access our battery. Wonderful, and with that we are now finally ready to mount our front wedge. To do this, I'm just going to hot glue this exactly where I want it to sit on the lifting arm. Then we can just drill our 2 bolt holes where the Lexan pieces meet. Then bolt the 2 pieces together. And wahalala, here we are with one beautiful lifter ready for action. Now we are finally getting so close to the end that there's really only 4 super small things left to do. And those things are, number 1, attach the lifting servo to the arm so it can actually move it. Number 2, attach some small strip of metal to the front of the lifter so I can actually get up underneath other robots. Number 3, attach a power switch somewhere in the robot so I can easily turn the robot on and off. And lastly, which is my personal favorite, number 4, give this thing a wicked awesome paint job. And by paint, I probably mean decorative tape. So let's just go ahead and start knocking these things out one at a time. So for the lifting servo, I'm just going to go ahead and bolt on this little bent piece of Lexan I made to the lifting arm. And then we can just attach the servo lifter arm to the wedge's lifting arm by either a rubber band or string. That way the servo can bring the wedge back down. I had experimented with a couple different ways for the servo to lift up the lifter arm, but I like this way by far the best. Not only is it super compact, but it's also super skinny, which allows it to sit on top of everything, and plus, since it sits on top of everything, it doesn't run the chance of getting tangled with anything, because it's on top. I feel like that didn't make any sense. Plus, since I didn't use a middleman bar to attach the servo to the lifter arm, we also have a lot more torque. That definitely didn't make any sense. So needless to say, I really like this setup, and it's actually pretty similar to how the original Talyn worked. On to the front wedge. Here is some very thin sheet metal that I picked up at Lowe's for like $6. What a good price. For the competition, I'm going to cut out a very small little sliver of this and attach it to the front bottom of my wedge so I can get up underneath other robots, because like I said, it's so stinking thin. But since this isn't the actual wedge I'm going to be using, and I don't want to scrape up the floor when I test this spot, I'm just going to use Curd Bird as a stand-in for this video. Look at that, practically the same thing. Amazing. Now the next thing on our list is the power switch, and this is mine. I actually made this one myself. It's modeled after the FingerTech screw switch. I've actually never owned that switch. I don't even know if it's called that, and I'm not 100% sure how that switch works, but I'm pretty sure it works like this one. Basically all it is a small housing with 2 nuts in them with leads attached to each nut. So in order to complete the circuit, you just drive a bolt through it, but in order to open the circuit, you back it out. As you can notice, I also have 2 bolts sticking out of the top, but those are just mounting bolts. Those are going to hold this switch in place inside my robot. The whole thing tightens up very snugly, so hopefully I won't experience any trouble. Now I'm of course not selling this because this is a knockoff of the FingerTech one, but if you want to buy the FingerTech one, I'll leave a link for it down below. No, I'm not going to lie, I'm not 100% sure where I should mount this. I was originally thinking underneath one of these Lexan sides, but I'm going to have to remove the side to get the battery out, and that might be kind of a problem, but at the same time, I don't think I have any other choice. I can't really bolt it on the perimeter of the bot because all of that's been spoken for, so I guess when life gives you apples, keep the doctor away. Okay, so I'm going to have to be somewhat quiet because I may or may not be wiring this at like midnight. But anyway, I decided to mount it on the bottom of the base plate. So the screws are going through the bottom of it and it's just mounted right there. And look at that, amazing. We can reach the screw without having to alter the lifter at all. However, the side plate, we are going to have to cut a small hole in. But I'm very happy with that. That looks like it fits there well. The battery fits in there well. I'm just mad. I was originally going to put the switch over here and I had to break off part of the servo, but then it didn't work out, so I broke the servo for no reason. Oh well, it works. I'm happy. Let's move on. With that complete, there's now only one thing left to do, and that is to give this bot a wicked awesome design. But there is a problem. We are hardcore flirting with the weight limit right now. According to my calculations, we're probably only about 10 grams, maybe even closer to the max weight limit. Granted, the new wedge should save us about 10 grams of weight, but it's hard to know for sure until we actually have it. Regardless though, we're going to have to find the lightest way to decorate this possible. So I think I'm going to use red duct tape, which is actually a lot heavier than you'd think it would be, and red construction paper, which is about half the weight of duct tape when compared inch to inch. If my math is good, which honestly you never know, this should only cost us about 5 or 6 grams of weight. And I know that's a lot, particularly since we're so close, but I'm pretty sure we can make it. So I'm going to go ahead and get to it, and I'll see you guys on the other side. And here we are. Now before we move on, I do feel important to note when it says Talyn Alpha, that is supposed to signify that this is the most advanced Talyn that has ever existed. The Alpha among all the Talyn versions. By no means supposed to mean it's the best robot ever made or anything crazy like that. Speaking of previous Talons, this one's the same length as the one before, but a ½ inch wider and also a little shorter. Because this Talon is like exactly an inch thick, whereas the previous version was like 1.25 inches. And most of that size difference is actually because of the armor. The previous version used Lexan sheets, which are super thin, whereas this version uses 9 or 10mm thick HDPE. So hopefully it'll take bigger hits. And internally it's very different as well. This version's drive motors have twice the speed, twice the torque, and the tires have twice the traction as the previous version. So I guess it's a year of twos. The lifting servo is also twice as powerful, actually a little bit more. The previous version had a 9 kg servo, this one is 20. Plus this one's a little bit faster, but not a whole lot. The last servo, how I had it set up, it could flip 1-pound robots, but it took a little bit of time because it strained some under the weight. However, this one, it can flip 3 pounds pretty easily. The last version ran off a 3-cell 500 milliamp battery, which as you can see, it is a stinking beast, whereas this version runs off a 2-cell 300 milliamp battery, which is a whole lot smaller and a lot lighter. When everything was said and done, the previous bot came in 40 grams underweight, but this one is going to be a lot closer to the limit. So let's drop it on a scale and see where we're at. Okay, so I have my scale zeroed. The weight limit is 453 grams, that's 1 pound. So if we drop on a robot, it weighs in at, whoa, 453.2 grams. You know what? That might actually be under a pound. Oh my land. So I just looked up 1 pound is 453.5 grams. So my bot is under the weight limit by 0.3 grams. That's pretty crazy. Now granted, I am going to use a different lighter lifter. It's probably going to save me about 8 grams or so. And plus most competitions have a few gram forgiveness, but still, it was pretty crazy it was that close. So now that we know for sure that this thing makes weight, praise the Lord, let's go take this thing out for a spin. In the red corner, roses are red, violets are blue. I kinda finished my bot. Whoop-de-doo, it's Talyn! The judge's decision is in, and it's unanimous. Yup, that was the most painful thing any of us have ever seen.
You suck, you loser.
In the blue corner, I'm gonna win because I have a plan. Watch out for my butler because I'm Batman. It's Bruce. Oh, no, I'm sorry. Oh, Batman.
I'm Batman.
It's robot attacking each other time.
Bloop, bloop, bloop.
Ah. Now, as you just saw, Talyn can pretty easily self-right. The lifter can go from here, way back here, and throw that robot over without any trouble. However, a problem I experienced last time is when I went to flip other robots, oftentimes I would miss and the lifter would go way back, which would waste time, and plus I would throw weight back, which would lift up the front of my robot, and it would take more time for it to close. Super uncool. So what I've done this time to fix that problem is just simply 3D printed a little part that goes over my lifter stick. This part naturally stops the lifter just high enough to flip other robots, but not high enough to waste time or throw off the center of gravity. But hold the phone, I still need the lifter to go all the way back to self-right. No problem, as you can see there's a little cutout on the side, so I just push the lever over, go up, and it can self-right. So with this, you have a lot more control over your lifter without even having to think about it. Plus, there's a little tiny lip right there which stops this from rolling over on accident. I thought it was cool. not gonna lie, I'm quite happy with this. It has good speed, a strong lifting force, and I'm very much so looking forward to fighting it. And so there you guys have it, the new and improved Antweight Talyn. Now, like I mentioned in the beginning of this video, I am fighting Talyn very soon, and by soon I mean like, oh yeah, tomorrow. I'm super excited and scared at the same time, but that's BattleBots. Hopefully Talyn's ready for it. So please feel free to wish me luck, and I'll probably upload the fight footage in about 2 weeks. Or if you're from the future, a link for it is in the description down below. But hey, thank you so much for you guys waiting for this video and watching it. I hope you enjoyed it, and if you did, please feel free to hit the thumbs up and subscribe. And Lord willing, I'll see you next time.
Thanks for watching, and please feel free to subscribe.